Okay, so this problem is from 4-9 Lesson Master. This is what is on your review if you haven't noticed, but this is the correct version. On your review, there's a typo. So just like our notes, at the start of the ride, how high is Dizzy off the ground? At the start of the ride, no time has passed, so remember that t equals 0. Okay, so if I plug in a 0 here for t, then what I really have is, for this part right here, is I have pi over 90 times negative 30, because t is 0. So when I multiply this and reduce, I'm going to get negative 30 goes into itself once, and it goes into 90 3 times, negative pi over 3. So really what I have here is, d equals 65 plus 60 times the cosine of negative pi over 3. Now, we all know that the cosine of negative pi over 3 is about right here. Okay, negative pi over 3. And the cosine, you go over 1/2 positive and down root 3 over 2 to get here. So the cosine here is going to be 1/2. Okay, so again, the cosine of negative pi over 3 is 1/2. So that's really equal to 65 plus 60 times 1/2. And that is going to give us 95 feet. Okay? How long does it take Dizzy to make one complete revolution? One complete revolution is, all the way around a circle, so that's from 0 to 2 pi. So that really represents the period. Okay, so period equals 2 pi a. Okay, and in this case we have 2 pi. Now what is our a in this case right here? Remember, we have something being multiplied times our variable, okay? This is like our x right here. We have something being multiplied. We want that to be in the denominator to know what our a is. So again, being multiplied by pi over 90 is the same thing as being divided by the reciprocal. So we will multiply by 90 over pi. Okay, that's our a from this equation. Pi's cancel. 2 times 90 equals 180 seconds, which is 3 minutes. Okay, now what is Dizzy's maximum height above ground? Now again, on the unit circle for cosine, the maximum is 1. So where in the unit circle is the cosine equal to 1? That is going to be right here. Okay, again, so the maximum for cosine is 1, but remember we have an amplitude here of 60. Okay, so we have 60 times 1. Again, you're multiplying all your y values by 60 when the amplitude is 60. And then we also have a vertical shift of 65. So your vertical shift of 65 plus that amplitude of 60 is going to be equal to 125 feet above ground. Okay, if the ride lasts for 9 minutes, find all times at which Dizzy is at his maximum height. So again, we want cosine of theta to be equal to 1. Theta has to be 0. So we want our theta to be equal to 0. So if I set this equal to 0, okay, I would multiply by the reciprocal of pi over 90, and that will, we'll just get 0 on this side. Multiplying anything by 0 is 0. So we have t minus 30 equals 0. So that gives us t equals 30. Okay, so the first time is 30 seconds. Okay, it takes 30 seconds, but then each revolution, we want to keep getting back to that point. Each revolution is 180 seconds. So if I add 180, the next amount of seconds is going to be 210. add 180 again. The next amount of seconds will be 390. That's the maximum amount of times we can fit, 390 seconds. You can't go over that to stay within 9 minutes. Also remember on the review that you guys got, this is, the review key, there's another example for a Ferris wheel problem. This is actually the first part of the example from 4.9 notes. So again, in the notes, remember we said to let t be equal to 0 when the ride starts. So when you let t equal to 0, you have to find the cosine of negative 2 pi over 3. And you guys already know how to find that. The cosine of negative 2 pi over 3 is negative 1/2. So we have 25 plus 20 times negative 1/2 gives you 15 feet. That's how far off the ground the ride starts. Again, 1 complete revolution, the period, is the length of 1 revolution. So we fill this in. Remember our A, right here, this is being multiplied out in front. So our A is going to be the reciprocal